So we did a whole big lesson, a warm-up lesson. So we should be able to go through this a little bit quicker. The first section is general form, where the a is 1. Remember, the a value is whether it opens up or down. So if it's just opening up with a equal 1, these are superbly easier to factor. Okay? General form, where a is 1. They give this a special name. That special name is inspection. This is where you have to find those two special numbers that multiply to the c value and add to the b value. Now when we were doing the warm-up, didn't I put AC here before? But what's A? 1. And what's 1 times C? 1C is just C. Okay, so it's still the same as before with the decomposition. When A does not equal 1, you have to do a little bit of harder strategy. It will tell you, like right here, it's the coefficient on the x squared. Yeah, it's a good question. It's the coefficient on the x squared. So if we look at the first few examples, what two numbers are going to multiply to 30? Okay, well we have 30 and 1. That's not going to get me to 13. 15 and 2. Ooh, that could get me to 13 maybe if 2 is negative. But I don't think that one's going to work. Got 10 and 3. 5 and 6. 10 and 3, that's the one. So that, what I just showed you there is like a brainstorming strategy. You look at the factors. And then inspection is easy. You just write out the brackets, and then you insert those values that you chose right into the brackets. And that's those are the two factors. Okay, and then you can just double check with foiling. X times x gives x squared. X times 3, x times 10, that makes the 13. And then 3 times 10 makes the 30. Okay, I like that they gave you the exact same question, but with a minus sign on both. So which one's going to work now? Okay, good. 15 and 2, but which one of those? How did you know it was negative 15 and positive 2? Yeah, I always like to think of it as like who's winning? The negative 1, so make the bigger number negative. So then it's x minus 15 and x, oh, that was ugly, x plus 2. So this, I'll use my pointer. When you have a minus times a plus, the product will be negative. Okay, and then if the product's negative, this can be positive or negative, depending on who wins. And then one more, with the same 30, so it's the same factors. I wonder which one's going to work now. Yeah, now it's 5 and 6, but they have to go to a negative sum and a positive product. How do you get two numbers to multiply to come out positive? Yeah, two negatives. A minus 5 and a minus 6. What happens when you add those? You get negative 11. What happens when you multiply them? Positive 30. So this is inspection. Okay, so that's inspection. General form where a is 1. At the bottom of this page, they're going to give you the difference of squares. This is just a special case of the inspection, but the b value is 0. So the two factors have to add up to 0. So let's take a look at this one here. What two numbers multiply to negative 16 and add to 0? Yeah, negative 4 and plus 4. So then when we factor this difference of two squares, One is plus 4 and one is minus 4. Remember we did that in the quiz, which you should still have in front of you? Quiz question 2. So the difference of squares is a special case where the b is 0. And to make the b 0, you have to have the same term. One's positive, one's negative. Okay, we keep going. I'll do one of these for you. T minus 8, t plus 8. Notice how I draw my t's. I got a little hook on them. That's so they don't look like plus signs. I find with some people with math, you just want to eliminate things that can be annoying because it's hard enough as is. So writing t's like plus signs is one of those things. Okay, so I'll pause the video, give you guys about a minute here. Good, x minus 7, x plus 7, excellent. Go to the part C. Okay, how'd you guys get part C here? Okay, and the last one. Easy enough, right? Okay, so we talked about that earlier in class, so that works out nice. Okay, what happens if your expression in general form has a common factor? Well, in good factoring processes, you always want to take out the GCF first. Do that first anyway. So, okay, just do it. So for example, this one here with the 2x squared and the minus 50, what do they have in common? Well, they don't actually both have x, do they? So you can't take out any x, but look at the book is prompting you to take out a 2 because both of those terms are divisible by 2. What if you divide that by 2? You get x squared, yeah, the 2, and then yeah, good. Minus 25. And then this right here is a difference of, that's a difference of 2 squares, right? So then you get x plus 5 and x minus 5. So even the stop note says the exact same thing I said. When factoring, always take out the common factor first. Okay? So what's common between these two? A 5. Take out a 5. This is in your mind's eye. You have to imagine dividing both of those by 5, and that goes in this bracket. Divide them each by 5. X squared minus 4. Are we done? What is that, Trevette? All right, good. No wonder you're such a good dancer, because you probably have a good, what do you call it, like structure, logical sequencing. You need all that for dance. You have to memorize procedure, right? Okay, let's look at h of x here. So, guys, what you can do, 16 and 64, like they're both even, so I know they divide by 2. But is there a better factor? So the best way to do this is to check if 16 actually is a factor of 64. And then if it isn't, go lower. And then eventually you'll run out of options. So 16 is actually a factor of both. So you can take a 16 out of both, and you get x squared minus 4. So it's x plus 2 and x minus 2. Okay, let's take a look at g of x. Is there a common factor for g of x? So this is what I want you to think about. In the last one I said use 16 and check. For this one, what would you want to use? Yeah, 2's the lowest one, so at most you can only divide by 2. So check if all those divide by 2, where they're all even, so they will. So this is where you have to be careful. When you take out a 2, how big of a bracket should you have? Well, you should have a bracket that will fit all 3 of those terms after division by 2. So divide each one of those by 2. You get x squared, 8x, and 15. They're just all scaled down by 2. You could imagine if you put this 2 back inside, you'd be back here. But we don't want to go backwards. We don't want to undo our factoring. Sometimes students will start foiling. But this is now we're always factoring now. Now, are we done? You have to double check. Could you make 2 factors out of this? Are there 2 special numbers that make 15 that add to 8? What multiplies to 15? So, and those add up to 8. So those are the ones you want. And then for letter D, I'll just give you a tip because I can't handle anything like this. It's too hard for me. I just can't do it. So you just have to watch. So what did I do? 3 is the common factor, but I took out a negative 3. Okay, that is just done to make my life easier. If I would have just taken out a 3, then I would have had a negative on the front of the x squared, and I haven't shown you one of those at all. So, and then even when we get to math 30-2, this is a good strategy for one of the units there. So I'll just put a star here. Factor out a negative when the lead coefficient is negative. So then, could this be factored more? So you can see what I've done here. I just write the brackets. I put the x in there because I know I'm going to make an x squared. And then I just try to think. Oh, this is actually quite nice because 3 is prime. So what are the only numbers that are going to multiply to 3? 1 and 3. And then you can write them down, 1 and 3. And then you can decide on the sign after that. Like, which one wins? It got to be ended up negative 2. So it should be negative 3 and a plus 1. Okay. Binomial common factors. This is quiz question 3. This quiz question 3 is just sort of a stopgap between when the a value is not 1. That one's harder to do. So they show you this just to like a little warm up. Okay, this is like you're doing a little stretch before you jog or go for a sprint. Yeah, like does a lion stretch out before he attacks a hyena or gets his lunch? Does a lion stretch out? Okay, anyways. What do these guys have in common? Yeah, it's a binomial that they have in common. What's in common on this one? And then the one down here? And the one over here. Okay, so in all of these, you have 2 terms. And in each term, they have a common binomial. So take it out. X minus 9. It's been, in your mind, removed. It's been divided out. So that's gone, that's gone. What's left over? The 3x and the negative 2. By definition, this is actually what distribution is. So the x minus 9, the whole thing is going to multiply 3x. That's this. And then the x minus 9, the whole thing times is minus 2. That's this. Okay? What do I take out of the second one? 2x plus 1. What's left over? 5x plus 7. Now for part C, this one is always a hard one to explain. But when you take out the 2x plus 1, I mean the 9x is easy, but what do I put here? Good. Who said that, Ryan? Good job, man. Because there's a little 1 here that you don't see. It's not written. You know what? Let him have his due, alright? Trying to steal his thunder. And the lightning. Okay, let's do the next one. Take out the 3 minus 2x, and then you're left with 8 plus x. There's a problem with this one, though. If you look back on my last slide, what does this say? Factor out a negative when the lead coefficient is negative. Look at this lead coefficient. So this one would actually be better served if you took out a negative. That becomes negative 3 and plus 2x. How do you guys feel about me factoring out a negative? Now it still looks weird. It looks kind of odd. Why don't we just reorder them? Doesn't that look so much better? Doesn't that look better? The x's are in the front like they should be. The lead coefficients are positive. Okay, still more training wheels here. We're almost there, guys. This is where I want you to grab the GCF pairs. What's in common in the first pair? You're left with? Huh? Huh? Thank you. What comes out of the next one? What comes out of the next pair? 6 or positive 6? You're like, dude, that's the same thing. But I want you to write the positive. Because it's not a product yet. It's still a sum of two terms. Because we're factoring in groups. We haven't made it a product yet. Divide those 2 by 6, you get? Now it's the exact same question as above. Take out the x plus 4 and you're left with x plus 6. Okay, let's do the one underneath. What's coming out of the first pair? 9 is odd. It's not a competition. Okay, the first pair, you can take out a 3x. You're left with, careful, 2x minus 3. Good. Now what comes out of the next pair? Wow. How did you know that? Yeah, you can see that you could probably take out a 2, right? But why in this case do you want to take out a negative 2? Yeah, because the lead, yeah, it's like for this pair, the lead coefficient is negative, and you don't want that. So take out a negative 2, and then what happens to those signs? They change. If we didn't take out a negative 2, if we took out a positive 2, that would say negative 2x plus 3, which is not the same as this first term. And you wouldn't have this nice next step. No, we're going right to 326. So I'd call this like a negative trick. Now you can take out the 2x minus 3, and you get 3x take away 2. Yes. Yes. Okay. Next one. What's coming out of that first pair? What's coming out of this first pair? Can't take 8 out of 2. You can take out a 2. Can you take out an x? 2x. What are you left with when you remove 2x? X minus 4. Good. Now what's coming out of the second pair? Morley. It is 3. But you're not going to say anything else because other people try. Thank you, sir. So now what can come out, guys? Yeah. Good, x minus 4. And then you're left with? Very nice. You guys getting good at this now? Okay, here comes a hard one. Here comes a hard one. This one's on Mr. Kata. Come on, QB1, step up for a challenge here. Oh, what's coming out of 8 and 4? Let Carter do it. What comes out of 8 and 4? And then, yeah, good, 4a, beautiful. What's left over when you remove that? Divide the first one by 4. 2a, good. Divide the second one by 4a, you get? Ah, very nice. Now, this is where it gets interesting. Look at the next pair. It is exactly 2a minus 1, and 2a and minus 1 don't have anything in common, except for 1, which changes nothing. And that's a weird thing, too, for some people. It's like, oh, I guess that's the same thing, isn't it? And then now I can take out the 2a minus 1, and I'd be left with 4a plus 1. And now the last one. And I want you to be able to, some of you are spotting patterns like George is spotting a dime in Seinfeld. You guys ever watch that show? He spots a dime from across the room and then he bites into an onion. Because his glasses are all messed up. This is a crazy episode. Yeah, he's spotting dimes from across the room, but then he bit into an onion, thinking it was an apple. Couldn't see close, but he can see far, yeah. Okay, look at part C here. You see how 2a minus 1 only had a 1? Well, like, what about this second group? Like, they only have a 1 in common as well, right? But, like, look at the signs. plus minus, and then minus plus. So what should you take out of this one? What's the lead coefficient? So yeah, we're going to want to take out a negative here. And think, if I want to make the first pair look like that, what do I got to divide by to get to 2? How am I going to get to 2? What's the GCF for 16 and 8? 4. There's a better one than 4. Yeah, 8. And they both share an 1x, so then you're left with 2x minus 1. And then if you look at this 2x minus 1, it's so close to this. It's so close to this. So you just take out a negative. Because 2x is almost the same as minus 2x, they just differ by a negative. And same for the positive one and the minus one. And then you get